So welcome the students again for the other questions which are also very important, like question number 15, which I have given you in assignment. If A1, A2, A3, B and AP, it is given that A1, A2, A3 and so on B and AP. Okay, prove that, and we have to prove that one by A1, A2. So think about the relationship between A1 and A2 plus 1 upon A2 into A3. So think about the relationship between A2 and A3 plus 1 upon A3 into A4. So think about the relationship between A3 and A4 and so on up to 1 by n minus 1 at term and an. So think about the relationship between an minus 1 and an, means relationship between two consecutive terms. And we have to prove that this sum is equal to n minus 1 upon a1 into n. You must have thought about the relationship between a1 and a2, which is similar to that of a2 and a3, and which is similar to that of a3 and a4, and which is similar to that of an minus 1 and an. So is there any relationship which is between a1 and a2, and the same relationship between a2 and a3, and same between a3 and a4, and same between n minus 1th term and the nth term? So if we think about the relationship between A1 and A2, so it is very clear that if we find the difference between A1 and A2, it is equal to the common difference, and it is also equal to A3 minus A2. This is the relationship between A2 and A3 also. And now if we find the relationship between A3 and A4, it is further A4 minus A3 equals to A5 minus A4 and so on. So common difference is A2 minus A1 equals to A3 minus A2 equals to A4 minus A3 equals to A5 minus A4. So this time, if we find the difference between the reciprocals of A1 and A2, that is 1 by A1 minus 1 by A2, it is giving the denominator as A1, A2, which we have to bring. And the numerator becomes A2 minus A1, and we know that A2 minus A1 equals to D. So it is D upon A1, A2. So 1 by A1 minus 1 by A2 equals to D upon A1, A2 can be taken as equation 1. Now further, if we add 1 by A2 with 1 by A3, it is again A3 minus A2 over denominator is A2, A3. Now A3 minus A2 means D again. So D upon A2, A3 is equation number 2. Then 1 by A3 minus 1 by A4 equals to LCM is A3, A4, numerator is A4 minus A3. Fourth term minus third term is again equal to common difference upon A3, A4, which is the equation number 3. And further moving, if we write the second last n minus 1 and last an reciprocal, then their LCM is an minus 1 into an, and in the numerator they are giving an minus 1. So the difference between two consecutive terms is again D upon an minus 1 into an. And if we write one more, the second last, an minus 2 minus the reciprocal of third last, second last is an minus 1 and third last is an minus 2. So the denominator is again an minus 1 into an minus 2. So an minus 2 minus an minus 1. So it is again equal to D upon an minus 1 into an minus 2. So this is equation number 4 and this is equation number 5. So hope you all must have understood all the discussion till now. Now, if we add all the equations, what do we get? On adding all the equations, we get 1 by a1 minus 1 by a2 plus 1 by a2 minus 1. Very clearly, this 1 by a2 and 1 by a2 will be cancelled out. 1 by a3 and 1 by a3 will be cancelled out. And finally, an minus 2, an minus 1. This is wrong. Yeah? We have to write an minus 1 actually. So we observe again an minus 1 cancelled out before this, an minus 2 minus an minus 3, it has cancelled, and similarly all the terms will be cancelled out except the term at the end 1 by n and the first 1 by a1. So if we add left hand sides of all the equations, we get 1 by an as the positive term minus 1 by a1 as the negative. That one was not wrong. Sorry. Minus 1 by a. And previous is okay. So an minus 1 is cancelled out from an minus 1. An minus 2 already been cancelled out. So 1 by n and 1 by a1 from the first equation remains. So if you do something wrong, you can check it directly. 1 by a1 from first term and 1 by an from the last equals to, in right hand sides, when we add all these terms, we observe that the numerator d is common between them, and then the inside the bracket 1 by a1 a2 plus 1 by a2 a3 plus 1 by a3 a4 and so on up to 1 upon n minus 1 into a. It implies, now if we take LCM in this also, a1 into an, so numerator is an minus a1 equals to d is common into 1 by a1 a2 plus 1 by a2 a3 and so on up to 1 by an minus 1 into a. An minus a1 is also a1 plus n minus 1 into d minus a1 over a1 into an equals to d into 1 by a1 a2 plus 1 by a2 a3 and so on up to 1 upon an minus 1 into an. It implies this a1 cancelled out, so it is only n minus 1 into d upon a1 into an equals to d into 1 by a1 a2 plus 1 by a2 a3 and so on up to 1 upon n minus 1 into an, and so dd will be cancelled out from both sides. In the remaining term, if we write this in the left hand side, so it is 1 by a1 a2 plus 1 by a2 a3 and so on up to 1 by an minus 1 into an equals to, in the right hand side, we write the left hand side of the previous line, n minus 1 upon a1 into an, and this is what we have to prove in this question in the proving. Okay, so hope you all must have understood this one also. And the main factor, the principle behind it is the difference between a2 minus a1 is 2. So if you have done this, even if you have done some mistake, you can solve it easily. So clearly solve it after watching the video again and again. Okay.